Hello and welcome to our channel again, Suraj here. And today we are going to solve the Jee Advanced 2018 Magnetism question, which is totally based upon the a charge in a magnetic field. So this is a quite easy question that is asked in the Jee Advanced. So here the question is saying that there is a magnetic field B1 and B2 in the two regions, as we can see that in the first quadrant there is a magnetic field B1, and in the fourth quadrant there is a magnetic field B2, and there is a relation between these two magnetic fields. And what happened is that the magnetic field is in the k cap direction, and it's acting whenever the y is greater than 0, and a charged particle with velocity pi meter per second is thrown. So what will happen? We have to find the average speed in the x-axis. It means we all know that the particle will travel the circular motion or a semicircular motion. Then it enters into B2 magnetic field. Then it will also do the our is yeah, no, in the question, we have to find out the average speed in the x-axis from the below, not from the top. So what will happen is that when this particular charge particle will move, so it will firstly move in the first quadrant, then it will move in the second quadrant, and then it will enter into the first quadrant again. Then we have to find out the average speed on the x-axis. So let's understand this question and solve this pretty easy question. सो हम लोग देखते हैं कि चार्ज पार्टिकल का मोशन कैसे होगा. फर्स्ट ऑफ ऑल अगर इस चार्ज पार्टिकल को हम लोग थ्रो करेंगे तो ये एक सेमी सर्कुलर पाथ पे मूव करेगा एंड देन इट विल मूव इनटू द B2 मैग्नेटिक फील्ड. एंड सिंस B2 मैग्नेटिक फील्ड जो है वो 4 गुना है B1 से, तो यहाँ पे उसका रेडियस कम होगा और वो फिर एक्स एक्सिस पे ऐसे कुछ मूव करेगा. तो हमको क्या पता करना है कि जितना इसने एक्स एक्सिस पे डिस्टेंस कवर किया, ना कि डिस्प्लेसमेंट. इसलिए हमको एवरेज स्पीड निकालना है, डिस्प्लेसमेंट देखना होगा. तो हमको इसके एक्स एक्सिस से टोटल डिस्टेंस को इसके टाइम से डिवाइड करना होगा कि हाउ मच टाइम इट विल टेक टू कवर दिस डिस्टेंस, and then we can find out the average speed. So let imagine that this is the radius r1 in the B1 magnetic field, and this is the radius r2 in the B2 magnetic field. So let's solve the question. So first of all, we have to find out the radius of this particular two semicircles. As you can see that how we can find it using the centripetal force. As in this case, the centripetal force is provided by the magnetic force, which is the Lorentz force. F is equals to QV cross B, which is the cross product between the velocity and the magnetic field. We are going to equate mv square divided by r is equals to qvb, and we can cut down some things, like we can cut down velocity, and here we can also velocity. So the formula for the radius will be mv divided by q into the magnetic field. So in this first region it is b1, so here radius will be mb divided by q into b1. Let's say this is radius 1. Similarly, for the second semicircle, we can find this result. mv square divided by r2 is equals to qv b2. So v2 के वैल्यू को हम लोग पुट कर देंगे 4b1 से, ताकि हम लोग इक्वेट कर सके और आगे फर्दर एजम्पशंस और कैलकुलेशंस कर सके. So mv square by r2, then again we are going to cut down the velocity here. mv divided by r2 is equals to q into the 4b1, because it is b2. Then we will find a relation. Putting the value of relation, what we can do is that the radius 2 is equals to mass into velocity divided by q 4qb1. So how, first of all, what is the distance here? So distance will be what? These 2 into Rn, which is diameter, then this 2 into R2. So the total distance, let's say D, let's say our total distance D is equals to 2R1 plus 2R2. We can substitute the values. 2 into R1 is 2mv divided by q into B1, and plus 2 into R2 will be mv divided by q into V1. If you will add this, I think you're okay. If you will add this, it will become 5mv divided by 2qb1. So this is the total distance. What we are going to find is to find out the time period, that how much time period this charged particle will be in the magnetic field B1 and the magnetic field B2. So there is a simple straightforward formula for this. Formula is equals to, for time period 1, let's say in the first semicircle, time 1 is equals to pi m divided by q into B1. Simply for the second part, it will be pi m divided by q B2, and since putting the value of V2 as 4B1, time 2 will be pi m divided by 4qb1. Now we have to add the time period. Total time t is equals to t1 plus t2. By adding t1 plus t2, it will be 5 pi m divided by 4qb1. Now we have to find out the average speed, total distance traveled by total time taken. This is a simple thing. Average speed v is equals to the distance here we have calculated, which is 5 mv. Putting the value of velocity as pi, it will be 5 pi m divided by 2q b1 into 4q b1 divided by 5 pi m. This and this will cut out. This and this will cut out. 2, 2. So the answer of this particular question is velocity is equals to 2 meter per second. So this is the J Advanced 2018 question of the magnetism. This is pretty easy question in comparison with the other questions because it is straightforward. We can do this particular question by doing some of these formulas and calculations directly, not very a tricky problem. So this is a quite nice problem also, fundamental problem. I've also made a Telegram channel where I share the problems of the International Physics Olympiad and the INPHO. So you can join our Telegram channel also. Alternative days, I also different types of quantum mechanical questions I also post. So free to join this particular channel. It will be amazing to do the different types of the questions of different physics Olympiad, not of only Indian physics Olympiad, also the different types of physics Olympiad like APHO, which is the Asian Physics Olympiad, and all that things. So join our channel. So for today's, thank you for watching my video.